Hello to everybody. Hello to everybody. Welcome back to Brand Institute of Forensics and Security. And we are doing well with our course. And today we are again focusing on fire safety protection. And we are going to learn something about fire suppression and fire extinguishment. Fire suppression and fire extinguishment. This is under lesson 5 of fire safety protection. My name once again is Mr. Wayne, and I am happy to be conducting this presentation or bringing to you this presentation. I hope so far you are learning something about fire safety. I am very confident that you are at least up to date with the current terms used in fire safety management, fire safety protection, fire safety issues. Therefore, under lesson 5, we are going to look at issues related to fire suppression. And we say fire suppression or extinguishment means to stop or put out fire in order to prevent its spread and consequent damaging effects. Fire suppression or extinguishment means to stop or put out fire in order to prevent its spread and subsequent damaging effects. We know that the spread of fire has got serious consequences, including death. You have seen what has happened in our republic, including damage to property, damage to assets, and fire can consume an entire premises or an entire business until you are unable to recover in business. Therefore, fire suppression or fire extinguishment means to stop or put out fire in order to prevent its spread and consequent damaging effects. The theory of putting out a fire. The theory of putting out a fire is based on an interruption or taking away of one or more of the essential elements in the combustion process. When you take out one or more of the essential elements in the combustion process, for example, if you remove oxygen, for example, if you remove fuel, for example, if you remove any other element, then that is actually related to the fire extinguishment theory. With flaming combustion, the fire may be extinguished by reducing temperature, eliminating fuel or oxygen, or by stopping the uninhibited chemical chain reaction. So we say reducing temperature, which is cooling, eliminating fuel, which is starving, and also removal of oxygen, which is smothering. We are going to look at these things as we move ahead. If a fire is in the smoldering mode of combustion, only 3 extinguishment options exist: reduction of temperature, elimination of fuel, or elimination of oxygen. So if the fire is in the smoldering mode of combustion, only 3 extinguishment options exist: a reduction of temperature, elimination of fuel, or oxygen. Let's look at extinguishment by temperature reduction or removal of the heat of oxidation, which is called cooling. This is the earliest and most common method of extinguishment, and one of the common ways in which it is achieved is by cooling with water. Cooling with water, we are reducing the temperature. This process is dependent on cooling the fuel to a point when it does not produce sufficient vapor to burn. Cooling by water is effective in solid and liquid fuels with high flash points. Cooling by water is effective in solid and liquid fuels with high flash points. So just remember, reducing the temperature, it is called, in other words, cooling, and the most effective and the earliest and the most common method is from the earlier period is by cooling with water. So when you pour water on the burning material, on the burning chemical reaction, when you pour water on it, then you are cooling, you are reducing the temperature. And then we say low flash point liquids and flammable gases cannot be extinguished by cooling with water, or as vapor production cannot be sufficiently reduced. So low flash point liquids and flammable gases cannot be extinguished by cooling with water, as vapor production cannot be sufficiently reduced. To reduce the temperature, the extinguishing agent must be applied in adequate amounts as in proper form to establish a negative heat balance. Please read that statement on your own, write it down, and try to understand it. That to reduce the temperature, the extinguishing agent must be applied in adequate amounts and in proper form to establish a negative heat balance. B. Extinguishment by fuel removal, which is starvation or separation. Extinguishment by fuel removal, which is starvation or separation. This can be accomplished by stopping the flow of the unburned liquid or gaseous fuel, or by removing solid fuel in the path of fire. This is in order to separate the fuel from the already burning fire. One can also allow the entire fuel to burn until it is completely consumed. I usually like using the example of the 3 stones at our rural home, where we put 3 stones and then we put fire underneath, wood underneath, and then we put the cooking pot on top. Now we are making soup, for example, and then we put firewood in between the 3 stones, which we have made as stove. When we remove the firewood, we pull the firewood from the fire, then that is what we call starvation or separation, which is fuel removal. We are removing the fuel that is necessary to support combustion to continue. And then C, we have extinguishment by removal or dilution of oxygen supply, smothering. It's called smothering. This method aims at reducing the concentration of oxygen to the fire area. This can be accomplished by introducing an inert gas into the fire or separating the oxygen from the fuel, e.g., smothering the fire with a fire blanket. A fire blanket. You all know a fire blanket. Fire blankets exist at almost all facilities, especially where we have a kitchen, especially in the hotel industry. Fire blankets will be found in the kitchen or in some of the engineering areas. This method of extinguishment does not work for on self-oxidizing materials or on certain metals, as they are oxidized by carbon dioxide or nitrogen, the 2 most common extinguishing agents. Carbon dioxide also prevents combustion by displacing the oxygen in the air surrounding the fire. Then we have also the extinguishment by chemical flame inhibition, modification of the combustion chemistry. Some extinguishing agents, such as dry chemicals and halogens, interrupt the flame producing chemical reaction, resulting in rapid extinguishment. This method is effective only on gas and liquid fuels, as they cannot burn in the smoldering mode of combustion. If extinguishment of smoldering material is desired, the addition of cooling capability is required. So this is extinguishment by chemical flame inhibition or modification of the combustion chemistry. Some extinguishing agents, such as dry chemicals and halogens, interrupt the flame producing chemical reaction, resulting in rapid extinguishment. So from the figure above, you can see we have starvation, we have cooling, and we have smothering. You can see on the side of the triangle, When we actually remove oxygen, we are smothering. And on the side of the triangle, when we remove heat, we are cooling. And also when we remove fuel, we are starving. These are some of the basic concepts that should be at your fingerprints as relates to putting out a fire. Putting out a fire involves cooling, smothering, starvation. Remember, when we talk about these things, we are only referring to fire in the initial stages or small fires. But when it is a fire that is in the growth stage, that fire that is now rapidly spreading, then we cannot afford to put it out by cooling, smothering, and starvation. However, cooling sometimes it can be applicable, especially when we use fire engines. When we use fire engines, or when we use hydrant systems, we draw water under pressure from hydrant systems. Then we may still put out a huge fire by cooling. Let's proceed. I hope from this triangle, from this figure, you can learn something regarding putting out a fire. Now, ideal extinguishing agents for the respective fire class. Ideal extinguishing agents for a respective fire class. We have class A fires. Class A fires involve normal combustible materials or normal combustible solids. And the extinguishing agent mostly is water, CO2, foam, and dry powder. Water is most commonly used to suppress these fires. Class A fires, fire involving normal combustible material. We are talking of rags, we are talking of wood, we are talking of rubbish, we are talking of waste. This kind of normal combustible solids. Normal combustible solid. Class A fires, the most commonly used agent to suppress these fires is water. Let's look at class B, which is flammable liquids. Mostly extinguishing agents for class B type of fire is CO2, foam, and dry powder. These fires are put out by excluding air, by slowing down the release of flammable vapors, or by interrupting the chain reaction of the combustion. Use of water on this class of fire is likely to increase the rate of burning dramatically and to disperse the fuel to cover a greater area. It is advisable to shut off the fuel supply before extinguishing the fire. Take note, use of water on this class of fire, which is class B type of fire, which are flammable liquids like paraffin. It is likely to increase the rate of burning dramatically and to disperse the fuel to cover a greater area. And then class C type of fire, which is gas. Extinguishing agent is CO2, foam, and dry powder. It is recommended that the fuel supply be shut off before extinguishing the fire. Shut off the fuel supply before extinguishing the fire. I want to say something here before we continue. You as a security officer, you as a security professional, you have to know where we have these valves, especially if the premises has got a gas cylinder, huge gas cylinders, or several gas cylinders. You should be able to know where are the shut-off valves, so that in the event of a fire, then you can rush quickly and shut off the supply before attempting to extinguish the fire. Again, I want to say, you as a security officer, you as a security professional, there are some things you must be aware of. For example, we say using water on class B type of fires will drastically increase the fire. Using water on let's say an electrical fire, you know what is likely to happen. So as a security officer, as a security professional, these things should be at your fingerprints, so that when there is at your fingertips, so that when there is a call for you to respond to a fire situation, the moment you reach the scene, the first thing you do is to conduct an immediate assessment. First of all, determine which class of fire is this, and then quickly think about the appropriate equipment to use. And then after you have done the assessment, you have to ensure that you are safe and nobody is in danger before you can attempt to put out this fire. You must be able to act very fast. You must be able to react very fast. And you can only act very fast. You can only react very fast if you know what you are doing, if you know the kind of situation you are going into. Initially, when we did the introduction, we spoke at length about smoke and the danger of smoke. So you should be able to make an assessment with immediate effect and conclude that this is a fire that I can put out, or this is a fire that I need to call for help immediately, and this fire is beyond my ability or my ability to extinguish it. You should be able to make that assessment immediately. Let's look at class D, which is combustible metals. Combustible metals. Extinguishing agents for combustible metals is CO2 and dry powder. A heat-absorbing extinguishing medium is needed for fires in combustible metals. Also, the extinguishing medium must not react with the burning metal. This makes water an unfavorable extinguishing agent. Dry powder covers the burning metal and provide a smothering blanket. So class D, which is a type of fires involving metals, the best extinguishing agent is CO2 and dry powder. Forget about wood. Class E, electrical fires. Electrical fires. We also saw most of the fire hazards are caused by electrical ignorance or electrical issues. We say electrical fires, extinguishing agent, CO2 and dry powder. Where a fire involving an electrical hazard can be expected, the extinguisher must be electrically non-conductive, in addition to having the correct classification for the materials involved. An advantage of carbon dioxide is that it leaves no residue after the fire is extinguished. When electrical equipment is not energized, extinguishers for class A or B fires may be used. The marking of E on the fire extinguisher indicates the extinguisher is safe for extinguishing a fire involving energized electrical equipment. So if there are sockets, a television, you are in the control room, the monitors are on fire, the DVR rack is on fire, you immediately conclude this is an electrical fire, then you have to think of CO2 and you have to think of dry powder. You have to think of CO2 and you have to think of dry powder. And where you have these equipments, especially in the control room, ensure that there is a CO2 fire extinguisher inside the control room or a dry powder fire extinguisher inside the control room. This is very important. Even in the server rooms where we have racks for these electrical equipments related to CCTV surveillance, ensure that we have CO2 and dry powder extinguishers in these locations. We have another class of fire which is called K or F fire. This is fats and oil fires. Extinguishing agents are wet chemicals, especially in the kitchens where cooking happens a lot, or in the engineering area where we have oil, diesels, and whatever, or where we are likely to encounter fats or oils. The high temperature of the oils when on fire far exceeds that of other flammable liquids, making normal extinguishing agents ineffective. Where the high temperature of the oils when on fire far exceeds that of other flammable liquids, making normal extinguishing agents ineffective. Not all extinguishing agents are compatible with all types of fuel. Hence, if the wrong type of extinguishing agent is selected, the fire situation can be made worse, often threatening your own personal safety. So, as a security officer, you must familiarize yourself with these fire extinguishers. You must know which agent is suitable for which class of fire to avoid putting your life into a serious situation. Some extinguishing agents are simply more effective than others on particular classes of fire. Some extinguishing agents are simply more effective than others on particular classes of fire. Having said that, we can see uh, several types of fire extinguishers here. We can see a fire blanket. We can see dry powder, which is usually color-coded blue. We can see CO2, which is color-coded black. We can see water, which is usually color-coded red. We can see wet chemical. You can see the color, and you can see foam. Remember, fire blankets are very important, and fire blankets are very effective at smothering the fire, which is actually cutting off the oxygen supply, which is one of the elements for fire combustion. So you must be able to familiarize yourself with these equipments, and not only familiarize yourself, you must know how to use this equipment. I am very confident, and I have seen that in many organizations, many employees and many security people do not know how to simply operate a fire extinguisher. How to simply operate a fire extinguisher using the acronym PASS, which is PASS, which you should be able to exercise, and you should be able to understand the meaning of this pass, which is pull the pin and then assess the situation, and then hold the hose, and then sweep from side to side as you press the contents from the extinguisher. We shall go through over that, and you will get to understand the meaning of actually this acronym: spray and sweep from side to side to extinguish the fire. You aim, and then some other words that you are supposed to use. But pulling the pin is one of the tasks that most people find difficult to do. There's usually a tie-up that is fixed between the pin and the levers of the extinguisher. So you have to cut off the tie-up, and then you have to remove the pin, and then you have to hold the hose, and then you have to aim, and then you have to press, to squeeze the contents from the extinguisher as you sweep from side to side, aiming the base of the fire. However, sometimes when we use a dry powder fire extinguisher, you pour the contents on top of the fire to act as a blanket, to smoother, to cut off the supply of oxygen. I am telling you, as a security professional, as a security person, you must have this knowledge at your fingertips, because fire safety is an integral part of security management. When we talk about security management, I mentioned this is in another class. When we talk about security management, we talk about fire safety, we talk about first aid, we talk about CCTV surveillance, we talk about investigation of breaches, we talk about occupational health and safety. Those are some of the integral things in security, the integral things that make up what we call security. The reasons why you patrol, the reasons why you monitor the facility using CCTV surveillance, the reasons why you have people at access points. It is simply those basics of security: fire safety, occupational health and safety, CCTV surveillance, issues related to first aid, among others. Types of fire suppression. Types of fire suppression. 1. Manual fire suppression involves the use of human-aided equipment to suppress fire, e.g., portable fire extinguishers, hose reels, and dry and wet razors. Whereas automatic fire suppression involves the use of automatic non-human aided devices to suppress fires, e.g., automatic sprinklers, gaseous fire suppression, and condensed aerosol fire suppression. So types of fire suppression, or types of how to cut out a fire: manual fire suppression and automatic fire suppression. There are two: manual fire suppression and automatic fire suppression. Manual involves use of human-aided equipment to suppress fire, e.g., use of portable fire extinguishers, hose reels, and dry and wet razors. Whereas automatic involves the use of automatic systems, non-human aided devices to suppress fire, e.g. automatic sprinklers. And then fire suppression system, again, methods of applying extinguishing agents. Now, methods. There are two common methods for applying fire extinguishing agents. Two common methods. Method number one is total flooding. Method number two is local application. Other specified application methods are expulsion, suppression, and inerting against expulsions and fires. We say fire suppression systems using total flooding. Systems working on a total flooding principle apply an extinguishing agent to an enclosed space in order to achieve a concentration of the agent, volume percent of the agent in air, adequate to extinguish the fire. These types of systems may be operated automatically by detection and related controls or manually by the operation of a system actuator. This is true for any gaseous total flooding agent, irrespective of its mechanism of extinguishment. So number one, we have total flooding, and we say total flooding works on the principle where systems working on total flooding principle apply an extinguishing agent to an enclosed space in order to achieve concentration of the agent or volume percent of the agent in air, adequate to extinguish the fire. Total flooding is the most common system application of halons and has been employed for the protection of volumes containing essential electronics, machinery, spaces on ships, aircraft engines, and cargo bays, and closed process modules in the oil and gas industry, and both crew and engine compartments on military armored vehicles. Halons. Read more on this because halons are becoming extinct because they have an effect on the ozone layer. Read more about the use of halons. And then fire suppression system using local application. In local application, the agent is applied directly onto a fire or into the region of a fire. There are some systems employing this technique, but the most common method of local application is by manually operated wheeled or portable fire extinguishers. In these instances, this method is also referred to as a streaming application. One example of a local fire suppression system is the protection of wet benches in the semiconductor manufacturing industry. So local application, the agent is applied directly onto a fire or into the region of a fire. For example, if you are using a fire extinguisher directly to apply the contents onto a fire, then that is called local application. Fire suppression system types. Fire suppression systems is a terminology used to describe the system used to extinguish a fire based on either the type or of agent or equipment. Number one is based on agent. A fire suppression system can be water mist, foam, wet or dry chemical, condensed aerosol, gaseous, clean agent suppression systems, etc. And then based on equipment, a fire suppression system can be portable or fixed fire suppression system. This is based on equipment. A fire suppression system will basically consist of the agent storage containers, agent release valves, we say based on agent and based on equipment. Based on agent and based on equipment. A fire suppression system will basically consist of the agent storage containers, agent release valves, fire detectors, fire detection system, wiring control etc panel, actuation signaling, agent delivery piping, and agent dispersion nozzles. Keep those things in mind when we talk about fire suppression system types. Two types, based on agent and based on equipment. Then we say based on extinguishing agent. Gaseous fire suppression systems, clean agent fire suppression system involves the use of inert gases and chemical agents to extinguish a fire. It is also called clean agent fire suppression. The agent may be delivered by means of solid propellant gas generators that produce either inert argon, CO2, or chemically active gas. Gases can inhibit the chemical chain reaction, reduce temperature, or dilute oxygen supply, hence extinguishing the fire. Advantages are clean agents, hence don't require cleaning and good for use in dirt sensitive environments. So the advantages of gaseous fire suppression system is that they are clean agents, hence don't need to require cleaning after it has been applied. Then we say water suppression systems. This is basically the use of water to extinguish fires. These systems are based on air pressurized water, APW. Water cools burning material by absorbing heat from the burning material. Is effective on class A type of fire. Advantages: water is inexpensive and readily available. It is also harmless and relatively easy to clean up. So water suppression systems: one, gases suppression system; two, water fire suppression systems. And then we have water mist fire suppression system. Water mist uses a fine misting nozzle to break up a stream of deionized water to the point of not conducting electricity back to the operator. The water is broken from one stream into a mist to increase the surface area of the fire that the water would cover. Are effective against Class A and Class C fires. Water mist fire suppression systems can be delivered via dedicated pump systems or by stand-alone cylinders. Advantages: require low water volumes required in comparison to fire sprinkler systems. This means that pipework diameters and storage capacities decrease accordingly. Those are the advantages of water mist fire suppression systems. Requires low water volumes. Then we have, it is also harmless and non-contaminant, unlike other clean agent suppressants, hence good for use in places like hospitals and laboratories. Environmentally friendly, effective since it is easy to increase the water droplet surface through manipulation of pressure and nozzle design. Area into mist, creating a large interface with the fire, hence achieving much greater heat absorption efficiency. The mist created protects against radiated heat and helps to prevent fire spread. Those are some of the advantages of the mist water suppression systems. And then we say 4, aerosol fire suppression system. Aerosol. An aerosol is a suspension of solid or liquid particles in gaseous medium. It can be a solid or liquid extinguishing agent in a gaseous medium. Condensed aerosol fire suppression is therefore a particle-based form of fire extinction similar to gaseous or dry chemical fire suppression. As with gaseous fire suppressants, condensed aerosol suppressants use clean agents to suppress the fire. The agent can be delivered by means of mechanical operation, electrical operation, or combined electromechanical operation from an aerosol generator. Then we say advantages. Condensed aerosols are flooding agents and therefore effective regardless of the location and height of the fire, unlike dry and wet chemical-based suppression systems, which must be aimed directly into the fire. So we say condensed aerosols are flooding agents and therefore effective regardless of the location and height of the fire, unlike dry and wet chemical-based suppression systems, which must be aimed directly into the fire. Space and weight requirements for aerosol suppression systems are minimal since they are condensed compared to other suppression systems. They are also easy to install and don't require pressure vessels or piping. Aerosol suppression systems are environmentally friendly compared to other suppression systems. Environmentally safe compared to other suppression systems. And then number 5, we have wet chemical fire suppression system. Wet chemical fire suppression systems are used in extinguishing oil and fat-related fires. Extinguishing oil and fat-related fires. Wet chemicals, potassium acetate, carbonate, or this what we call uh, uh, citrate, extinguish fire by forming a soapy foam blanket over the burning oil and by cooling the oil below its ignition temperature. The efficiency of wet chemical agents in extinguishing oil and fat fire is increased through addition of wetting agents, detergents to break the surface tension of water and improve penetration of class A fires, and addition of antifreeze chemicals to lower its freezing point to prevent water from freezing, hence ensure reliability. The wet chemical suppression system employs defense technology, gas generators, similar to the technology used in life safety applications, such as car airbags, which enhance safety, reliability, and enable complete monitoring of the system. So the wet chemical suppression systems employs defense technology, gas generators, similar to the technology used in safety applications such as car airbags, which enhance safety, reliability, and complete monitoring of the system. Then we have dry chemical fire suppression system. We have looked at wet chemical, then dry chemical fire suppression systems. This is a powder-based agent that extinguishes by separating the four parts of the tetrahedron. It prevents the chemical reaction involving heat, fuel, and oxygen. Fire is hence extinguished through the interruption of the combustion chain reaction. Agent examples are sodium bicarbonate, ammonium phosphate, and potassium chloride. Most dry chemical extinguishers use stored pressure to discharge the agent. Most dry chemical extinguishers use stored pressure to discharge the agent. And then we have also foam fire suppression systems. Foam fire suppression systems. Foam extinguishers use an aqueous film forming foam agent that expels a layer of foam when it is discharged through a nozzle. It acts as a barrier to exclude oxygen from the fire. Foam is a thick chemical froth applied to fuel fires as either an aspirated, mixed, and expanded with air, or a non-aspirated form to form a frothy blanket or seal over the fuel, preventing oxygen reaching it. Unlike powder, foam can be used to progressively extinguish fires without flashback. You can also research on flashback and you get to understand the meaning. Flashback is when you extinguish, but then after the fire is extinguished, then it flashes back and the fire restarts again. The fire reignites. Each fire system is designed specifically around the risk at the hand, giving complete flexibility and control. That is why I said you must be able to understand which class of fire is this and which extinguishing agent is suitable for this type of fire. Portable fire extinguishers. A fire extinguisher, flame extinguisher, or simply an extinguisher is an active fire protection device used to extinguish or control small or limited fires, often in emergency situations. Remember, in emergency situations, if the fire is huge, you can see its spread is very fast. It is in the growth stage of development. You cannot use a fire extinguisher. It is not intended for use on an out-of-control fire, such as one which has reached the ceiling, endangers the user, i.e., no escape route, smoke explosion, hazard, etc., or otherwise requires the expertise of a fire department. So fire extinguishers can only be used to extinguish small fires, fires in the initial stages, to control small fires or limited fires, most often in emergency situations. But a fire that is already out of control, do not attempt to use a fire extinguisher. Keep that one in mind. Typically, a fire extinguisher consists of a handheld cylindrical pressure vessel containing an agent which can be discharged to extinguish a fire. You already know this. Extinguishers use stored pressure to discharge the agent. Fire extinguishers are provided for a fast attack firefighting measure, generally undertaken by the occupants of the building before the fire services arrive. It is important that occupants are familiar with which extinguisher type to use on which fire. Fast security has to be aware of this. Most fires start as a small fire and may be extinguished if the correct type and amount of extinguishing agent is applied while the fire is small and controllable. We say most fires start as a small fire and may be extinguished if the correct type and amount of extinguishing agent is applied while the fire is small and controllable. That is why we say effective patrols, effective CCTV surveillance monitoring, effective walk around of the premises is very, very important by security officers, because if you discover fire in its initial stages, when it is still small and controllable, then you may use appropriate equipment to extinguish. I have seen this myself practically, especially at the Republic of Maldives where I used to work. I have seen staff extinguish small fires that would have otherwise led to catastrophic consequences. I have seen it. I have seen staff extinguish small fires that would have brought a lot of damage to the facilities where I was working. So patrols are very, very, very important, and also training and empowering people understanding which type of equipment to use on which class of fire are very important issues. The principal fire extinguisher types currently available include water, foam, carbon dioxide, dry chemical, wet chemical, and the special purpose. Special purpose. Special purpose are some type of fire equipments which have a yellow band, and they are used mostly on metal fires. You see water type, solid red, foam, red, blue band, carbon dioxide, black band, electrical fires, dry chemical, white band, flammable liquids and electrical fires. Dry chemical extinguishing agents extinguish fire by interruption of the combustion chain reaction. And then wet chemical, oatmeal band, fat fires. No, not electrical. Do not use wet chemicals on electrical fires. Those are some of the details that we need also to do more research and to understand them at a deeper level. And then we say note, fire extinguisher locations must be clearly identified. You must know where are the fire points or fire locations. Fire extinguisher locations must be clearly identified. Most fire extinguishers have a pictograph label or color coding that identifies the type of fuels that may be extinguished. Multipurpose extinguishers. The multipurpose extinguisher can be used on class A, B, C fires. They contain ammonium phosphate base, multipurpose. And then most portable extinguishers are rated for use with more than one classification of fire. An extinguisher that is rated for use with multiple hazards should include a symbol for each hazard type. Make a habit of just looking at the extinguishers and understanding on which fire hazard can I use CO2, on which fire hazard can I use dry powder, on which fire hazard can I use water type, on which fire hazard can I use wet chemical. You should be able to understand this because the information is readily available on the extinguishers themselves. Take time to study them and to understand them. And then we say also sand, from very long ago, from the earlier ages, sand buckets have also been placed at locations, at facilities to be used as a fire extinguisher. Also referred to as a fire bucket is a steel bucket filled with sand, which is used to put out fires. Typically, fire buckets are painted bright red and have the word fire stencilized on them in white lettering. They are placed in prominent positions in rooms or corridors. They are a low technology method of fighting small fires. The main advantages of fire buckets are that they are cheap, reliable, and easy to use. The fire buckets are usually made around bottom so that they cannot be used for other purposes. Fire buckets, e.g., hang on fire bucket stands. This is a very, very effective mode of a traditional firefighting equipment. And then fire blanket, we have spoken about fire blanket, used also to smoother small fires to cut off the supply of oxygen. And then also we say there are some other large fire blankets for use in laboratory and industrial situations, are often made of wool, sometimes treated with a flame retardant fluid. These blankets are usually mounted in vertical quick release cabinets so that they can be easily pulled out and wrapped around a person whose clothes are on fire. Uh, then the fire extinguishing balls, I hope you have also seen this one. They are new in the market. These are a modern ball or grenade style extinguishers. They are manually operated by rolling or throwing into a fire. The ball self-destructs once it comes into contact with the flame, dispersing a cloud of ABC dry chemical powder over the fire, which extinguishes the flame. One benefit of this type is that it may be used for passive suppression. The ball can be placed in a fire-prone area and will deploy automatically if a fire develops, being triggered by heat. Most modern extinguishers of this type are designed to make a loud noise upon deployment. Finally, we speak of a hose reel system. A hose reel system, you have seen in most facilities, we have hose reels and they discharge water under pressure. And these mostly are used to extinguish class A type of fires, which is normal combustible material. So water, these hose reels, I would wish that you do more personal research as an assignment on hose reels, where they are placed, the distance from one hose reel to the other, what are the requirements, what are the regulations for placing these hose reels. So I would like you to do a research on the materials that are used for these hose reels and where they are mostly used and the advantages of the hose reel system. Also, apart from that, do a research also on hydrant systems. Learn about hydrant systems. I think we have completed this presentation, which has taken us almost 50 minutes to complete. It was a little bit long presentation, but those are some of the fire suppression and extinguishment systems. Please go through it slowly, do on research. I will send you the notes also for further detailed information regarding these systems. Thank you very much. we will meet again in the next lesson. However, today I really wanted us to see if we can also have a look at case studies. So I think we can squeeze some time this weekend, and then we also cover case studies with this lesson. So I will shortly present case studies. We have a look at some of the major fires that have occurred in Kenya, and we see where we fell short of preventing these fires, and how the response was coordinated, and what could have led to the death of a high number of people. So thank you very much. See you when we go through the case studies.